so today we want to continue with our revision of the grade 11 work. We're going to speak specifically about Venn diagrams and proving events are independent. These are things that were done with you last year in grade 11. So the idea is that you know how to do this. I'm just reminding you about those skills. Okay, anyway, so let's get cracking. The first question that we're going to look at is a question where we would have to use our formulae, and our formulae are not given to us. We need to learn them, right? So the formulae that we would need to be able to answer question 7.1, the first formula is this one: the probability of A or B is the probability of A plus the probability of B minus the probability of A and B. Is that familiar to everybody? You know which formula I'm talking about. They sometimes call it your addition rule. Okay, Luzo says their screen is blank. I don't know why, Luzo. Maybe just log off and log back on again and see if that helps. Everybody else, you can see
Yes,
my screen,
please.
right?
Yeah, so
Yeah,
on my
okay,
side
all
is
right.
clear, and if not,
Oh,
please
okay,
do let us know. Like this
yeah,
teacher, Lee can unshare her own screen and share again if it
yeah,
doesn't work by logging
yeah,
out.
yeah, sure. Okay, so we should be familiar with that formula from grade 10. In fact, would have been the first time that they would have shown it to us. Not that we remember everything that we get shown, but we should recall this from grade 11 at the very least. Okay, so the first question doesn't actually use the formula. The second question is going to use that. But in the case of the first one, they want us to determine the probability of not B. Okay, so the probability of not B is going to be 1 minus the probability of B. So you can see over here, they've given us the probability of B, which is 0.55. So subbing in, we would say 1 minus 0.55, and that would give us 0.45, like so. Okay, oh, there we go, Luzo, it worked. Lovely, well done. All right, so 1 mark for that. That must just be for calculating the answer. In the case of the second question, they've asked us to determine the probability of A or B, but they've added an extra thing here. They said if A and B are mutually exclusive events. So if A and B are mutually exclusive events, how does that affect this formula? Can anybody recall from the start of our lesson last time we spoke about mutually exclusive events? Can anybody remember? There we go, Gugu. Well done. Perfect. Yes, and Nhlanhla, quite right. Both of you are correct. So for mutually exclusive events, because there is no intersection, this term over here has a value of 0. Quite right. Okay, so lovely. Well done. So for mutually exclusive events, we could say that the probability of A and B equals 0. So therefore, the probability of A or B is simply going to be the probability of A plus the probability of B. And we have both of those. That's given to us. So that would be 0.3 plus, try that again, 0.35 plus 0.55. Okay, so that would give us 0.90. Okay, let me just clear that up over there. Yes, the furthest bracket wouldn't be there. Quite right, Lebogang. That's another way of looking at it. Okay, so that's question 7.1.2. Good, well done, everybody. So here, I think they'd want us to show that, and then we'd get a mark over there as well. And then the last question here asks us to determine the probability of A and B, probability of A and B, if A and B are independent events. Okay, can anybody remember the rule that we would use if events are independent? Often referred to as our product rule. There we go. Well done, Cheslin. And in Nhlanhla again, good, well done. So the probability of A and B is equal to the probability of A times the probability of B. Yes, lovely, good. You guys know your probability really nicely. Okay, good stuff. So, and again, we know the probability of A and we know the probability of B. So we can go ahead and go and sub those in. And in this case, the probability of A and B, if these events are independent, would be 0.1925. I suppose they would expect us to round that to 2 decimal places, but I'm just going to leave it as 4 decimal places, just like that. Okay, any questions? That's it, Leanne, 0.1925. Any questions about that? Are these formulae familiar to you? You know what I'm doing here. Yes, yes. Okay, thank you, Lebogang. Thanks, Nolwazi. Okay, if that's all good, let's move on to the next question, right? So here, okay, Mamelo. In this case, they've said to us at Havens Boy High School, there are 150 learners in grade 11. The following information was compiled by their sports department. So they tell us 76 learners play cricket, 90 play rugby, 45 play basketball, 15 play cricket and rugby and basketball, 23 play cricket only, 12 learners play basketball and rugby but not cricket, and 30 play cricket, rugby but not basketball. The first thing that they want us to do is sketch a Venn diagram or draw a Venn diagram. Sorry, just a question coming through. Ma'am, for 712, are the events mutually exclusive? Yes, they told us that. Okay, so that's why we said that the probability of A and B was equal to 0. Okay, because these events are mutually exclusive. If they were not mutually exclusive, then the probability of A and B would not be 0. Okay. All right, so just coming back to this, when you draw, if they ask you to draw a Venn diagram, 99% of the time, they will give you something where you've got 3 different events, right? So the easiest thing for you to do is draw the circles first. Okay, so I'm going to draw one circle and then a circle that overlaps that. Oh gosh, those are terrible circles. And then a circle that overlaps that as well. Then put the box around. Okay, obviously you guys would use a ruler. I'm not using a ruler. I'm doing this freehand on my pad. So that makes it a little bit more difficult. Then the other thing that you should write down is the number that you have in your sample space. So in this case, we have 150 learners. Now, before I jump in and start filling in numbers all over the place, let's just talk about what the different regions mean, okay? So I'm going to call this one cricket, this one rugby, and this one basketball. Okay, so this area over here in the center, what does that represent for us? All 3, absolutely. So when we say all 3, do we use the word and, or do we use the word or? and. Good, Gugu. Okay, so this bit that's yellow in the middle is cricket and rugby and basketball. Okay, so these are learners that play all three. Okay, so cricket and rugby and basketball. All right, so that's the word and. If I now take a different color highlighter and I highlight, I'm going to have to draw this again, but anyway, it doesn't matter. And I highlight this region in blue. How would you describe that region? What words would I use for that region? Let me just move it into the center of the screen. What would you call that? The turquoise blue, what would you call that? What you guys are saying. Good. Okay, so just stay on mute, please. That's well done. Okay, so cricket and basketball. Good. So that's cricket and basketball. What happens if I excluded this region over here? How would you describe what's highlighted in blue now? How would you describe that? Careful, Mamelo. There we go. Pumzile. Careful, Nolwazi. That's it, Lebogang. Cricket, not all basketball, cricket and basketball. Okay, so cricket and basketball only. Oh, or we could say cricket and basketball, but not rugby. Does that make sense to everybody? That's it, Leanne. Okay, so cricket and basketball only, or cricket and basketball, but not rugby. Okay, is everybody happy with that? So we have to understand what the different regions mean before we can start filling in our numbers. Okay, so let me just rub that out. Then if I were to highlight, I'm just trying to get rid of that without having to redraw it. Then if I was to highlight this piece over here, how would I describe that? The one that I've highlighted in yellow. Good, well done. Rugby only. Well done. Awesome. Rugby only. Okay, very nice. And last question, what would I do if there were grade 11 students who did not play either rugby or cricket or basketball? Where would I put them? Okay, absolutely. Goes inside the square, but outside the circles. Lovely. Okay, very nice. Well done. Grade 12s, that's perfect. That's it. That's exactly where it goes, Leanne. Okay, good, Lebogang. Perfect. So now that I can see that you guys understand the different regions, it's going to make us filling this in super easy. All right. So I'm sure your teachers taught you this last year. When you read the information that they give you, go through each row carefully and try and find one that says all three. Okay, so start with that first. Can you see here, in this row here, we've got 15 learners play cricket, rugby, and basketball. We always want to start in the middle and work our way to the outside. So 15 is going to go there. What I like to do is just scratch that off so that I know that I've used it. Then I go back. Now you are looking for people that play both sports. So cricket and rugby, or rugby and basketball, or basketball and cricket. Okay, so let's go and have a look. Those are down at the bottom here. There are 12 learners who play basketball and rugby, but not cricket. So basketball and rugby, okay, but not cricket. That means the 12 will have to go over there. Then they tell us that there are 30 learners who play cricket and rugby, but not basketball. So 30 learners that play cricket and rugby, but not basketball, that 30 would go over there. If they had said that 30 learners play cricket and rugby, but they didn't, and they left this off, and that wasn't there, to work out how many played cricket and rugby, but not basketball, I would have to subtract. Okay, I don't have to do that in this case, but sometimes they expect you to be able to do that. So you'd have to say 30 minus the 15 in the middle. All right, but they haven't done that. Yes, Nolwazi, that's exactly it. Okay, but here we're filling the 30 in where it is because they told us they play cricket and rugby, but not basketball. Okay, so we've been able to fill in a little bit. If we knew how many people played rugby in total, we could fill in the space that I'd highlighted in yellow earlier and write down the number of people that play rugby only. So now we're going to go up here. We can see that there are 90 people that play rugby. Okay, so oopsie, I'm scratching that out. There are 90 people that play rugby. So that is everybody inside the rugby circle. So to work out how many people play rugby only, I would have to take my 90 and minus the 30, the 15, whoopsie, minus, and the 12. Okay, so how many people play rugby only? 33. Good, well done. Okay, because that whole circle has to add up to 90. Excellent, well done. So 33 people play rugby only. All right, there we go. Let's go back and see what's happening over here. Ideally, we'd like to try and fill in this area of intersection between cricket and basketball first. Let's see what we have not filled in. 23 play cricket only. Okay, well, that makes life a little bit easier. So that 23 is going to have to go over there. And then to work out what goes in the intersection between cricket and basketball, we could have a look. There are 76 that play cricket. So 76 in the cricket circle. So cricket and basketball, not rugby, is going to be that 76 minus 23 minus 30 minus 15. That's it. Okay, 8 people. Well done. Perfect. So 8 people play cricket and basketball, but not rugby. And then when we go back up here, what have we not used? The only thing that's still there, 45 learners play basketball. Okay, so 45 learners play basketball. So basketball, we would have 45 minus 8. So sorry, basketball only is what we're trying to calculate. Would be 45 minus 8 minus 15 minus 12. Good. Okay, so that would be 10 people. Now we've got to be careful. Good. Well done, Nolwazi. Well done, Renee. We can't just leave it now and move off. Remember, we spoke earlier, what happens if there are some students that don't play any of these sports? Okay, they've got to go on the outside. So now we have to add up all our numbers. Okay, so those who know cricket, no rugby, no basketball, we would have to take 150 and minus all of these numbers, 20, or you could add all the numbers together and then subtract it from 23. The choice is yours, but you've got to subtract all of those numbers, minus 8, minus 15, minus 12, minus 10. Is there anybody who doesn't play rugby? There we go. 19 people. Okay, so 19 people go here on the outside. All right. Okay. So we've drawn the Venn diagram. All right. So things, I suppose what they would do here is they would obviously give you a mark for constructing it in the correct way. So that 33 was something we had to calculate. The 8 was something we had to calculate. The 10 was something we had to calculate. The 19 was something we had to calculate. 1, 2, 3, 4, 5. I suppose that's where they would give us our marks in this case. All right, so now that we have drawn our Venn diagram, we are ready to answer a probability question. And in fact, we've pretty much answered the question already because they're saying to us, what is the probability that a grade 11 learner selected at random does not play cricket or rugby or basketball? So here, the key word is that they want the probability. Okay, so that means that we would have to take the number of students that do not play any of these sports and then divide it by the number of people in the survey. Okay, so in this case, the probability of those that do not play anything. Oh, there we go. Well done. You guys have got the answer before me. 19 out of 150. Perfect. And if you wanted to write that as a fraction or as a decimal, it really, really doesn't matter. Okay, so some of you I see are writing 0.13, which is what it would be if we rounded it to 2 decimal places. Okay, all right. Well done, everybody. That's perfect. So that seems to have gone pretty well. Are there any questions before I give you guys an opportunity to try one of these on your own?
Well done, guys.
I'm gonna try and make it, I want to make it a little bit smaller so that it's there, just to make it easier for you. There we go. Well done. All right. Hopefully you can see everything okay. What I
Yes,
suggest
it's
you
still
guys,
visible.
is it big enough?
Yeah,
Oh,
yeah.
good. Okay. So what I suggest you guys do is you don't have to take down the question, obviously, but quickly sketch the Venn diagram for yourselves. It doesn't have to be perfect. And then or actually, in fact, you don't even have to do that. If you can see the Venn diagram, it's okay. The first thing that they want you to do is work out the values of X and Y and Z. And then they've asked you 2 probability questions. All right. So you're going to have to look at this information that's here. All right, and then work out what X, Y, and Z are, and then the 2 probability questions. All right, so I'm going to give you guys 5 minutes to try that, and then we'll discuss our answers. Okay. Oh, sorry, just before we get started, Bohlale, can you want to take a screenshot? That's fine. There you go, Bohlale. I'll move it like that. You can screenshot the question. Oh, maybe what I should do, Bohlale, is just, I'll rub that out just so that you can see the numbers. Okay, if anybody wants to take a screenshot, you can do that now. All right, and then I'm going to scooch down again. Okay, there we go. Please continue working, everybody. And Nhlanhla? Yes, yes, that's also fine. That's also fine, absolutely. Okay, no problem at all. You'll get the same answer. Thanks for bringing that up, Nhlanhla. That's a good point. I'm just getting a pen, Yolanda. I'll be 2 seconds.
Okay. It's still trying. Still trying this question, guys. Let's go.
Mabena, that's not a problem at all. Were you able to get X, Y, and Z? And Tlantla, the answers you sent me are correct. That's lovely. Well done. Good stuff. Okay. So, Mabena, in question 7.1.2b, okay, Leanne, I got a different X value. Sorry. They're saying only two of the given meal types. So, Mabena, in the middle, that's somebody who eats all three. So people that eat only two are going to be the ones that I'm highlighting in pink. They eat two. Okay, the 53 in the middle eat all three. The pink ones eat two. And let's highlight the ones in yellow eat one food type only. The person on the outside, or people on the outside, however many there are in Z, They don't eat any. Okay, that's how it works. Okay. Gugu, let's see. Yes, yes, yes. I got the same answers for X, Y, and Z. Even me. Okay, yeah. So perfect, Gugu, perfect. Perfect, Nhlanhla. Lovely, 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 lovely. Well done. Good answers. Okay. All right, Lesego. Nolwazi, I got the same Y and Z, a different X, the same answer for A, but a different answer for B. Yes, Amahle, well done. Okay. Yes, Mabena. Good. Yes, Cheslin, your answers are correct. Mamelo, my answer for B was different to yours. But I think, Mamelo, your other answers, let me just check here. Did you send me anything else, Mamelo? Yes, your other answers were correct, Mamelo. Yeah, there we go, there we go, there we go. Yes, Mabena. Good. That's it, Cheslin. Yes, Matlet was correct. Okay, Mabena, mind you, I didn't. Oh, I think you just switched the numbers around. But yes. Oh, there we go. Yes, Cheslin. Good. All right. So a lot of you sending through some lovely answers. Thank you so much for attempting this question. Well done. So they want us to write down the values for X, Y, and Z. So let's just talk about where those came from. Okay, so first of all, if we go back, and I'll just rub that off so that we can see these numbers okay. Remember, X represents an area of intersection. Okay, so X is chicken and fish only. All right. The area with X and the 53, that is chicken and fish. So if I highlight this in pink, this is chicken and fish. So if you have a look over here, they tell us that there are 65 learners that eat chicken and fish. So in order to work out what X is, you've got to do what I was discussing earlier, where you're going to have to subtract. So 65 in total minus the 53, and that's where 12 comes from. Okay, that's it, Nolwazi, quite right. Then as far as our value for y is concerned, now that we know that x is equal to 12, working out this one becomes a little bit easier, right? Because they tell us over here that there are 86 learners who eat fish. So in other words, there are 86 people in this circle. So that means that y is going to be 86 minus 12 minus 53 minus 16, and that's where we get an answer of 5 for y. Okay, so y is 5. All right. And then the last one to work out what Z is, so Z's down here on the outside, these are the people that don't eat chicken or fish or beef. Remember, there are 100 students. So we would subtract 2 and 12 and 5 and 7 and 53 and 16 and the 3, and we would be left with 2 students. Okay, 2 students that do not eat chicken or fish or beef. Because, Johnny, the pink area is chicken and fish. So it would just be, it's just this area over here that I'm outlining in green. That's chicken and fish. Okay, so they've told me how many students eat chicken and fish. Okay, it's not chicken. So chicken is the whole circle. So I can't take away the 2 and the 7. Okay, if they had told me, like they did for beef and fish, how many students eat chicken, then I can do that. But they didn't give me that. So I can only use what they gave me, which is the 65 that eat chicken and fish. Okay, so remember, these ones here don't eat chicken and fish, and these ones here are not eating chicken and fish. Okay, Johnny? All right, so now let's go on and just quickly mark the second part. So 7.1.2 now. So now they ask us to calculate probability. So beef only. So probability that they eat beef only. So we can see that there are 3 that eat beef only. They also tell us that over here. So that's why you were saying 3 out of 100, or you could write that as 0,03, which is also fine. And then the last part. Okay, so only 2. As I was explaining earlier to Mabena, the people here in purple and there eat 2 of the meal types. Okay, the people in the middle eat all 3. So what I'm highlighting in turquoise, they eat all 3. The purple eat 2, and the ones in pink only eat 1 type of meal. All right, these people here on the outside don't eat any. So when we want to calculate the probability of eating 2, we would say 7 plus x, which was 12, plus 16 over 100. And that's why we get 35 over 100, which is 7 over 20. Or if you want to write it as a decimal, you're more than welcome to do that as well. Okay, not a problem. So the marks here would be for those values in 711 and 712. Answer only, this is out of 3. So I imagine here that they would have given you a mark for the answer, maybe a mark for the numerator. Where would the third mark be here? I don't know. I don't know. Maybe on the denominator. Not sure. And Ntlanhla, good question. So Ntlanhla's DM'd me and he said, what if the question said, calculate the probability that they eat at least 2 meal types? Good question. Okay, so probability of at least 2 means 2, maybe Lebogang, maybe. Although at grade 12 level, they should still mark you correct even if you don't simplify your fraction. Just like they'll mark your answer correct in calculus if you don't write your exponents, if you leave your exponents in the differentiation questions with negative exponents. Okay, so they shouldn't be penalizing you for stuff like that. Okay. I like this question, Ntlanhla, at least 2. What do you think the answer is, Ntlanhla? Two or more, exactly, Lesego. Exactly, 2 or more. So then that would be 7 plus x, which is our 12, plus our 16, plus those that eat all 3. Okay, good. Well done. Nice Good question, Nhlanhla. I like that very, very much. Well done. Okay, so at least 2 meal types. Brilliant. Okay, let's go on. We don't have a lot of time left. What I wanted to discuss with you now were two-way tables, also sometimes called contingency tables. Let's just put that here. So these are two-way tables. And sometimes they're also called contingency tables, although I don't know why we use the word contingency, but there we go. So two-way table, I think, makes a bit more sense. It often has to do with gender, and it's two ways because there's two ways of looking at the information. So the first way is on whether people eat chocolate or don't eat chocolate, and our second way is whether people are male or female. So this cell over here is male and eats chocolate. So the purple one is male and chocolate. The next one, male and does not eat chocolate. That's the pink. The turquoise is female and eats chocolate. And the yellow is female and does not eat chocolate. And then we total going in two ways. Stokozile, yes, sure, I'll go up again. There you go, just quickly screenshot. There you go, you've got the, oh, there you go. I hope you've got it, Stokozile. Okay. And then what they do is that they total these going in all the directions. So here you have the total number of people that eat chocolate. That's 80. Here you have the total number of people that do not eat chocolate. That's 70. And now that is totaled in this direction as well. There are 150 people that participated in this survey. All right, this 70 over here represents the number of men. And this 80 over here represents the number of females. And again, these have been totaled going in that direction as well. So the first question says, how many people participated in this study? There you go. Perfect. 150 people. Well done. Awesome. Now they want us to calculate some probabilities. So in A, it says, what is the probability of a male, of a person being male and being chosen? What would that be? What do you guys think it would be? That's it. Well done. 70 out of 150. And again, we could simplify. That's it. Good. So 70 out of 150. Okay, so that comes from this 70 over here that I'm drawing the darker blue ring around. Okay, there are 70 men that participated in this survey. What's the probability of eating chocolate? A person chosen that eats chocolate. That's it. Well done. That would be 80 out of 150 or 8 out of 15. Good. Okay, so eating chocolate and not eating chocolate would be mutually exclusive events. All right, just like male and female are mutually exclusive events. All right, just bringing that in there. All right, the other thing that they ask us is, are the events of being male and eating chocolate independent? Justify your answer with the relevant calculations. All right, so we know that our rule for independent events, because we spoke about it at the beginning of this lesson, was the probability of being male and eating chocolate. So I'll go, is the same as the probability of being male times the probability of eating chocolate. But we are not allowed to write this because we don't know that these are independent events. They're asking us, are they independent? So what we have to do here is work these out as two separate calculations. You cannot write that they are equal. So the first thing that we want to do is go and have a look at the block where you are to work out the probability of being male and eating chocolate. What is the probability of being male and eating chocolate according to this survey? What is the probability of being male and eating chocolate according to our survey? That's it. Well done, Gugu. Amahle Lesejo. Good. Well done. And Cheslin. Good. Luzu Lebogang. Nice. It is 45 out of 150. So what's useful in a situation like this, guys, is to get your calculator, put in your 45 out of 150, and then round it to a decimal place. So in this case, it's nothing exciting. It's 0.3. Okay, so what we're going to do is we're going to work out the probability of being male multiplied by the probability of eating chocolate, and then we're going to compare our answers, left-hand side with right-hand side. So probability of being male, we already know what that is from 8.1.2 part A. That's 7/15. We also know what the probability of eating chocolate is because that's our answer from part B of 8.1.2, which is 8/15. So now we're going to work out the answer to that. So if you press the SD button on your calculator, you get this. And I'm going to round this to 4 decimal places. Okay, so Gugu, it wouldn't be over 70 because then it would be only considering the males. Okay, so then it wouldn't be the total probability or the total number of people in the survey, should I say. Okay, so now we look at our two answers. Are they the same? No, right, they are not the same. All right, lovely, they are not the same. Okay, so good thing we didn't write that they were equal to one another because they're not. Okay, so that's why we cannot start off making that statement that they are equal because that's what we're trying to establish. Okay, so now we can conclude, therefore, the probability of being male and eating chocolate does not equal the probability of being male times the probability of eating chocolate. We must make this statement because it is the conclusion of our calculations. And now we would say, are the events of being male and eating chocolate independent? No, they are not. Okay, so being male and eating chocolates are not independent events. Okay, so that's 8.1.3. So very important when they ask you a question like that, are they independent events? You cannot start off assuming that they are. You've got to use the rule to test it, but you are working with the left and the right-hand side of the rule separately. Okay, so marks here. We'd have to get a mark. Probably a mark on both. Then a mark, mind you, I think I'm wrong. I think a mark here, and then this statement and explanation, there would be 1 mark. Okay, so very important. You have to write that the probability of being male and eating chocolate does not equal the probability of being male times the probability of eating chocolate. Are we all good? Are there any questions? Awesome. Okay. There was one more question. I don't think we're going to have time to do all of these. So what I'd like to do, actually, let me maybe make it a little bit smaller and then you guys can screenshot it a bit easier. You guys can try this one for homework. Let me just, there we go. And then you got the whole question.